Unsupervised learning is a machine learning technique where models discover patterns without supervision, dealing with unlabeled data. This approach is crucial for uncovering hidden structures in data, allowing models to work independently. Let's explore how these algorithms perform complex tasks, offering deeper insights into data. Unsupervised learning algorithms, like clustering and anomaly detection, tackle complex tasks without labeled data. They reveal hidden patterns, offering insights beyond traditional methods. While less predictable, these algorithms, including neural networks, are invaluable for data exploration and understanding. Let's explore how these techniques apply in real-world scenarios, enhancing our grasp of data's underlying structures. Imagine a baby recognizing a new dog by comparing it to a familiar one. This is unsupervised learning in action, where the baby identifies the new dog based on observed similarities, without explicit teaching. It highlights how unsupervised learning discovers patterns autonomously, offering insights into data without manual labeling. Unsupervised learning excels in discovering unknown patterns and features for categorization without manual labeling. It processes data in real time, making it efficient as unlabeled data is easier to obtain. This approach is crucial for analyzing vast data sets, providing insights that might otherwise remain hidden. Clustering in unsupervised learning identifies structures in uncategorized data, forming natural groups. Types include exclusive, agglomerative, overlapping, and probabilistic clustering, each offering unique methods for grouping data. These techniques help in organizing data without predefined labels, enhancing the discovery of inherent patterns and structures. Hierarchical clustering builds a hierarchy from individual data points, merging them into clusters. K-means clustering divides data into K-clusters, each defined by a centroid. Both methods uniquely organize data, offering insights into its structure. These techniques are foundational in unsupervised learning, providing diverse approaches to data grouping. K-nearest neighbors, KNN, classifies data by comparing similarities without forming a model. Principal component analysis, PCA, reduces data dimensions while maintaining complexity. These techniques enhance data analysis and interpretation, offering powerful tools for understanding complex datasets. Association rules uncover relationships between variables in large datasets, crucial for identifying patterns like frequent item sets in transactions. This technique is essential for market basket analysis and recommendation systems, offering insights into consumer behavior and preferences. Unsupervised learning applications are vast, including clustering, anomaly detection, and association mining. These techniques are crucial in fraud detection, customer segmentation, and data pre-processing, offering insights into complex datasets. They enable us to uncover hidden patterns and relationships, enhancing decision-making and strategic planning across various industries. Unsupervised learning lacks precise data sorting and labeling, leading to less accuracy. Users must interpret and label classes post-classification. Additionally, spectral properties of classes can change, affecting consistency. These challenges highlight the need for careful analysis and understanding when applying unsupervised techniques. Unsupervised learning uncovers hidden patterns in unlabeled data through clustering and association techniques. Despite its challenges, it provides valuable insights, enhancing our understanding of complex datasets. Embracing these techniques can lead to innovative solutions and deeper data comprehension.